Section 6-3, Properties of Logarithms and Derivatives of Logarithmic Functions of Base B. We have two objectives for today's lesson. Use properties of logarithms to expand logarithmic expressions and find the derivative of a logarithmic function with base B. And these are some references from your textbook. The main idea that we want to consider first is when you're trying to find the derivative of a logarithmic function, how do we want to do it? Well, we want to do it in a way that's easy for us to do. And this process becomes easier when you first rewrite your logarithmic function using the properties of logarithms that we learned in pre-calculus. So that's the main idea. So what are the properties of logarithms that we should know? There's the change of base formula, which we will consider later. But for now, we want to know three properties. One is the product property of logarithms. Another is called the quotient property of logarithms. And the third one is called the power property of logarithms. So the first one says if you have the natural log of a product, you can write that as a sum of two natural logarithms. So the natural log of the product AB is equal to the natural log of A plus the natural log of B. For the quotient property, it states that if you have the natural log of a quotient, you can write that as a difference of two natural logarithms, natural log of A minus the natural log of B. And the power property says if you have the natural log of A to the R, you can bring that exponent R to the front and write that as R times the natural log of A. So now let's take a look at an example to see how this is applied to a differentiation problem. So here we have a function, f of x is equal to natural log of a product, and the product is x squared times sine of x. We want to find the derivative of this function. What is the easiest way for us to do it? The easiest way for us to do it is to first rewrite this function using properties of logarithms. So up to this step, we're doing pre-calculus. Here, we're doing calculus. So we do pre-calculus to rewrite our function using properties of logarithm. This is called expanding the logarithm. So we can begin as follows. First, we see that we have the natural log of a product. So how will we expand this logarithm? By using the product property of logarithms. So we will have the natural log of x squared plus the natural log of sine x. And why is that? Because of the product property of logarithms. So in my problem, x squared is like a, and sine x is like b. So the natural log of the product AB is equal to the natural log of a plus the natural log of b. So I have the natural log of x squared plus the natural log of sine x. I can further expand this logarithmic expression by using the power property. By bringing the exponent 2 to the front, I can write 2 times the natural log of x using the power property. So now I have successfully expanded my original logarithmic function so that I have f of x is equal to 2 times the natural log of x plus natural log of sine x, and now I am ready to do calculus. I am ready to differentiate. And because of the expansion that we just did, the differentiation process will be easier for us. So how do we take the derivative of 2 times the natural log of x? Well, 2 is a constant, so we just have the constant, and the derivative of natural log of x, as you may remember, is 1 over the argument. So we have 1 over x. So that takes care of the derivative of the first term. Now how do we take the derivative of the second term? Before we begin, let's recognize that natural log of sine x is a composition of two functions. The inside function is sine x, and the outside function is natural log of x. So to take the derivative here, not only do we have to use the differentiation rule for natural log of x, but we must also use the chain rule because we have a composition of two functions. So the outside function is natural log, so the derivative of natural log is 1 over the argument, right? The argument here is sine x, so we write 1 over sine x. Now using the chain rule, multiply by the derivative with respect to x of the inside function. The derivative of sine x is cosine x. So we have 1 over sine x times cosine x, which is cosine x over sine x. Finally, we're going to rewrite cosine over sine as cotangent, and this is our derivative. Our process of finding the derivative was made easier because we first rewrote the function using properties of logarithms and then differentiated. Our next main idea is this. How do you find the derivative of a logarithmic function if it's not the natural logarithm, but it has a different base? For example, base 10 or base 3 or base 8. So here's the main idea. This is what we know. We know how to find the derivative of the natural log function. So how do we find the derivative of a function that has a different base? Here's how we're going to do it. We're going to go back to pre-calculus and remember something called the change of base formula. So what we have here is the change of base formula from pre-calculus. This allows us to change a logarithm with one base into a logarithm of a different base. So let's take our problem, which is log base b of x, and we want to rewrite that in terms of the base e, because if we can do that, we can use what we know from before to find the derivative. So how do we rewrite log base b of x? Well, here's the change of base formula. So when we change base from b to e, we will have log base e of x divided by log base e of b. But log base e is written natural log, so we have natural log of x divided by the natural log of b. And natural log of x divided by natural log of b can be further written in this way. B is a fixed base, so in a particular problem it might be 5 or 7 or 3, but it's a number. So natural log of b is a number, so you can write 1 over natural log of b, which would just be a number, a constant, times the numerator, which is natural log of x. So how does this help us with our objective? Our objective is to find the derivative of a logarithmic function with base b. So now that we've been able to rewrite our logarithmic function with base b as the natural log of x times a constant, we can use what we learned before about how to find the derivative of the natural log function to now find the derivative of a logarithmic function with some other base. So here's what we're looking at. To find the derivative of a logarithmic function with base b, you're going to rewrite your logarithmic function with base b like this, and then find the derivative of that. And it's a little bit not quite correct here because of the maybe some formatting that took place in the Word document, but I'll write it again so you understand. So the derivative with respect to x of log base b of x is the derivative with respect to x of 1 over natural log of b times natural log of x. And since 1 over natural log of b is just a constant, you're going to use the constant multiple rule to find the derivative. So it'll be 1 over natural log of b times the derivative with respect to x of natural log of x. And this derivative here is 1 over x. And so the final answer is, we have, let me write the final answer up here so you can see it a little bit better. So the derivative with respect to x of log base b of x is equal to 1 over natural log of b times the derivative of natural log of x, which is 1 over x. So when you multiply the two fractions, we get 1 over, 1 times 1 is 1, and natural log of b times x is x times the natural log of b. That's what we have here. So now we want to apply this formula to look at a couple of examples where we're finding the derivative of a logarithmic function with base b. So here we have example 2. F of x is equal to log base 3 of x. How do we find the derivative of this function? We use our newly derived formula. The derivative with respect to x of log base b of x is equal to 1 over x, or generally speaking, 1 over whatever the argument is, times the natural log of the base. Okay? So in this problem, the argument is x. So to find the derivative, we just apply this differentiation formula in a straightforward manner, and we have 1 over the argument times the natural log of the base. The base is 3, so we have natural log of 3. So that was an easy example. So the next example is a little bit more involved, because now we have a composition of two functions. Now we have natural log, not natural log, sorry, but log base 3 of cosine of x. So what we have here is a composition of two functions. The outside function is log base 3, the inside function is cosine. So not only are you going to be using the newly derived differentiation rule, but you will also be using the chain rule. So how do we do that? So here's how we do it. We're going to apply this differentiation rule to take the derivative of the outside function. And the differentiation rule says 1 over the argument times the natural log of the base. The argument here is cosine of x, so we have 1 over the argument, cosine of x, times the natural log of the base 3. And now we're going to follow through with the chain rule and multiply by the derivative with respect to x of the inside function cosine of x. So what is the derivative with respect to x of cosine of x? It is negative sine of x. And that's what we have here. So this is negative sine of x. And when you multiply negative sine of x to the fraction 1 over cosine x times natural log of 3, you get negative sine of x over cosine of x times natural log of 3. If you wish to further simplify, you can, and that's what I've done here. And what you can see is this. Sine x over cosine x is tangent x, and you have negative 1 over natural log of 3, and you have that as your final answer. In this lesson, we learned how to use properties of logarithm to expand logarithmic expressions, and we saw an example where we used this pre-calculus to first expand our logarithmic function, and then we differentiated, and that made the differentiation easier. And we just saw a couple of examples for finding the derivative of a logarithmic function with base b. For additional examples, you can refer to your textbook, read examples 3 and 4 on these pages, and you can do your homework.